Today's lesson we'll talk about exponential growth and decay. An exponential function is just an equation that's usually in the form of f of x equals a times b to the x. Don't let the f of x fool you. All f of x really means is y equals. So the equation is really y equals a times b to the power of x. It's an exponent. The value of a is going to be whatever you start out with. It's the current value. B stands for whatever the percent of increase or decrease is, but you have to write that as a decimal. This part is a big deal. The percent of increase or decrease has to be written as a decimal. And then x is going to be your time period. And that's always going to be your exponent. So here's the first example. The owner of a 1953 Hudson Hornet convertible sold the car at an auction. The owner bought it in '84 when it was worth $11,000. The value of the car increased at a rate of 6.9%. We need to be able to write a function that models the value of the value of the car over time. So when you start looking to see what you have here, this guy right here, the $11,000, that's the A. That's the initial value. That's what you had bought the car for. You also notice that you've got an increase of 6.9%. That's going to be turned into the B, and we'll figure out how that happens in a second. So equations, if we want to do it in y equals form, not f of x form, that is just fine. And it's going to look like this at the beginning. Y equals A, $11,000, times some value always to the power of x. Well, now here's where we figure out the percent of increase as a decimal. The car was worth 100% of the value when you bought it. It increases by 6.9%. So right now the increase as a percent is 106.9. But you have to change this percent to a decimal. Changing percents to decimal, you move your decimal place over 2 spots to the left. And the value that goes in here is 1.069. So the decimal is what goes in there. That's your equation. And now it says, well, the auction took place in 2004. What's the approximate value of the car at that time of the auction? Round your answer to the nearest dollar. So you need to figure out, well, how many years have elapsed from 2004, when the auction took place, to 1984, because we talked about when the owner bought it. The Hudson was a 53 Hudson Hornet, but it was purchased in '84. So the difference between these 2 years is 20 years, which means this is going to be your value of x. What you're going to do is have the equation $11,000 times 1.069 to the 20th power, to the 20th year. Here's where the calculator comes in handy. I'll show you 2 ways to do it. One way is to go right onto your home screen and to just type in 11,000 and then open up a parenthesis, 1.069, close your parenthesis, raise that to the 20th year, and get an answer. It asks you to round it to the nearest dollar. So 41,777.91 rounds to $41,778. So this answer is going to be $41,778. The other way to use your calculator would be like this. Actually type it into a y equals equation. Y equals 11,000 times the power, to the parentheses of 1.069, 0.069, and this time you're going to raise it to the power of x. You're typing in what you did on part A. Then what you do is you go to your table of values, second graph, and you go down the x column and you say, well, where is 20 years? And 20 years is right here. And in 20 years, here's your answer, $41,778. Either way is just fine on the calculator. Use it as a function this way, or do it on your home screen that way, doesn't matter. Next problem. This one says you put $250 in a savings account that earns 4% annual interest compounded yearly. You do not make any deposits or withdrawals. How much will your investment be worth in 5 years? So if we just if we model the function over time, then we know that y would be equal to the initial amount that you put in times some decimal to the power of x. Well, it's earning interest. That means you're getting that money. You're earning interest. So that means if I've got 100% of my money in the bank and I earn interest at 4% a year, that's my percent increase. But as a decimal, I have to use 1.04 in my parentheses. We know that you're talking about a 5-year time period because it says how much will it be worth in 5 years. So what you're going to really type in the calculator, or you're going to go to your y equals, it doesn't matter, is your exponent turns into a 5. This doesn't tell you how to round it, but we're talking about money. Money should always be rounded to the nearest penny unless otherwise noted. On the calculator, clear this out. We've got $250. We deposit in the bank. We get 1.04% interest and in, whoopsie, parentheses. And after 5 years, here's what our money is worth. $304.16. Okay, so $304.16. Here's a question they don't ask. How much interest was gained? So here's a question that they did not ask you, but I'm going to ask you. So how much interest was earned? And then you'd say, okay, well, if I end up with $304.16, but I started out with $250, how much interest was earned? Again, you could be able to do this by, obviously, you should be able to do it by hand, but all you would need to do is take this value, $304. This is actually showed up on the Regents, a question like this. I believe it was last year's Regents, the June of 2011. So 304.16 minus 250. So the interest that you earned in 5 years doesn't seem like a lot, but you didn't have to do anything for it, is $54.16. Okay, again, that was not a question, but I'm asking that just to make sure that you understand. Next one, the number of acres of ponderosa pine forest decreased in the western United States from 63 to 2002 by 0.5% a year. In 63, there were about 41 million acres of the pine forests. Write a function that models the number of acres of ponderosa pine forests in the western United States over time. So over time, we know that we started out with 41 million. Feel free just to write the number 41. You can also put the zeros after it. We should get the same answer either way. So it's 41 million. I know that I am decreasing, and it's decreasing by 0.05%. So if I've got 100% and I subtract 0.5, and you subtract 0.05, I said it again, 0.5. I'm sorry, let's try this one more time. And you subtract 0.5%. There we go. That gives you 99.5%. But as a decimal, you know what you're putting in here is 0.995 to the power of x. Question, to the nearest tenth, how many million acres of ponderosa pine forest were there in 2002? Well, what's the time period? From 2002 to 1963, a difference of 39 years. So then what you're going to do here is I'm going to go actually right on the calculator and do it that way as opposed to doing it the long way. So on the calculator, I'm not going to do it here. I'm going to put it in y equals. So in y equals, we're going to put in 41 million to 0.995 to the power of x. I'm going to go to my table of values, and I'm going to find my 39th year. Here we go. And in the 39th year, to the nearest tenth, there was 33.72 or 33.7 million. So the answer then is going to be 33.7 million. Okay, last one. A population of 90,000 decreases by 2.5% per year. Write a function that models the population over time. Y equals the initial amount, 90,000. Again, it's decreasing. So 100% minus 2.5% comes out to be 97.5%. But as a decimal, it's 0.975 to the power of x. What's the population going to be after 12 years? And then you are just putting in 12 for x. We'll do this one on the home screen, not in the y equals. Again, it doesn't matter how you do it. You should be able to do it both ways. 90, 0, 0, 0, parentheses, 0.975, parentheses, to the 12th year. It doesn't ask you about rounding in this case, so now you have to decide if you want to round it up or round it down. I will take one of two answers. If you want to write 66,419 people, because you can say that 0.85, a child wasn't born yet, that's fine. Or if you do 66,420 people, because the child's gonna be born, I'll take that also. So I'll take two answers here. So it's either going to be 66,419 or it's going to be 66,420. Okay, and that's it. So that should be hopefully enough to get you on with your homework.